So hello everyone. So welcome to environmental research seminar sponsored by Michigan Center on Life Stage Environmental Exposure and Disease, M-LEEaD. And I am very delighted to introduce today's speaker, Dr. Rita Strakovsky. So Dr. Strakovsky is currently an assistant professor of human nutrition at Michigan State University, where she is additionally affiliated with the Institute for Integrative Toxicology and Reproductive and Developmental Sciences program. So Dr. Strakovsky obtained her PhD in nutritional sciences and registered dietitian credentials from the University of Illinois, Urbana-Champaign in 2011. So she remained in Urbana-Champaign as an NIH T32 postdoctoral fellow in endocrine, developmental, and reproductive toxicology, and later as an NIEHS K99R00 grantee. While much of Rita's earlier training was in animal models of pregnancy, she currently evaluates the impact of various environmental and dietary exposures on the health of pregnant women and their children. Specifically, today's presentation will focus on the potential of maternal diet quality to mitigate the impacts of environmental chemical exposures. Rita will additionally highlight more recent findings related to novel approaches for evaluating diet quality in pregnant women. So please join me in welcome Dr. Rita Strakovsky.
Thank you so much. And thank you so much for the introduction. It's such an honor to be here. I don't have to repeat my title. I will say that this is a little snapshot of what we do, and I really wanted to share these diet data. Most of the the remainder of our work really focuses around women's health and environmental exposures. So this is a piece I really enjoy as well. So today I'm going to right on the surface, I won't go too deeply into methodologies or statistics. So if you have questions towards the end, I'm sure we have a little bit of time to address those. And please feel free to email me with any additional questions. So before I jump into everything I want to share today, I do want to thank the people who make this all possible, especially my research group here at Michigan State and at the University of Illinois. I'll highlight Diana Pasiga, who's the source of all of the data, or most of the data that I will share today, as well as our undergraduate students, collaborators specifically related to these projects, the team and participants of the iKids cohort, since I will be talking a lot about data from iKids, or mostly, as well as our finding from NIH. So I think I've presented some version of this slide since maybe graduate school, and I noticed yesterday when I was looking at it again that it's from October the 4th, 2010, so the timing is sort of perfect for today's seminar. And many of you have probably, who work in pregnancy, have probably used some version of this Time magazine article and related to specifically DOHAT, or the developmental origins of health and disease hypothesis. And this has shaped a lot of my training, a lot of my thought around pregnancy, and I'm quite proud of where our field has been and where we are now, specifically related to various outcomes that we know are programmed in pregnancy or can be considered as programmed in pregnancy. In my group, we primarily focused on metabolic and reproductive outcomes as being programmed in pregnancy, but certainly various others have been really extensively studied. With that in mind, today my presentation will really highlight some of the outcomes in relation to pregnancy outcomes. But as I mentioned, a lot of my research actually focuses on women's health. And so I wanted to throw this out just as keeping in the back of your head, since this is where it always lives in the back of my mind, that pregnancy is important because it produces babies, but also because it happens to women. So in a lot of ways, a lot of what I'll share with you today, despite the fact that our outcomes are really pregnancy outcome specific, that we're really trying to understand the implications of this both for fetal development as well as for women's health, both in pregnancy and postnatally. So specifically today, just two broad topics related to a recent paper we published related to dietary mitigation of paraben exposures. And then another kind of broad topic related to diet assessment and kind of thinking ahead about diet assessment. So maybe a little bit outside of the environmental health field, but as you'll see, it'll be relevant still. So getting started, in terms of our exposure of choice for today's presentation, my group primarily works within the realm of non-persistent endocrine disrupting chemicals, so phthalates, bisphenols, and today I'll focus on parabens, which maybe don't get as much notoriety as some of the others, but are still quite important. So parabens are certainly functional. They're antimicrobial agents in personal care products, specifically things like shampoos, lotions, cosmetics. There's been quite a lot of attention on parabens. Actually, if you're somebody who uses cosmetics or is at all interested in purchasing products that maybe don't contain parabens, a lot of companies really are advertising themselves as being more green or eco-friendly by excluding parabens. And this has been quite the sell because actually parabens are FDA regulated. And so they must be listed on the back of your product. So consumers have had an opportunity to sort of be participating in their own kind of selection of contaminants in terms of their purchasing power. And that's really quite a bit different compared to, let's say, phthalates and bisphenols, which are not listed on products. So just a little bit of kind of background on these compounds. So why worry about parabens in pregnancy? Kind of for the same reason we worry about many other environmental exposures, and that's because of the sensitive window of exposure framework, really knowing that pregnancy is a sensitive window for both the mother and the fetus. And so thinking about contaminants that potentially have been shown to be endocrine disrupting chemicals is critical specifically for this window. Parabens are also, so they're non-persistent and ubiquitous, and the two terms are a little bit oxymoronish, but in that, you know, parabens, like many other non-persistent EDCs, have very short half-lives. So within 24 to 48 hours, usually they're excreted in urine. But they are ubiquitous. So essentially, based on AHEI and our data and most other cohorts, report that 100% of reproductive age women have measurable levels of at least one compound, and AHEI specifically measures 4, and 4 of them are kind of commonly used in industry. And I'll show those to you in a little bit. Not surprisingly, women have higher paraben concentrations than men, and this is very similar again to phthalates, which are also found in personal care products. Experimental studies certainly have categorized parabens as EDCs, specifically with reproductive endpoints and pregnancy endpoints as well. And of course, epidemiologic studies have really started to understand the potential associations of paraben exposures with various birth outcomes. And this is kind of where we started. So Diana had an interest in investigating parabens several years ago, and so did I. And we sort of started where you usually start when you start thinking about pregnancy outcomes. We started thinking about fetal growth. It's a relatively standardized parameter to evaluate. And so she conducted sort of the first stage, you know, early graduate student literature review and did an excellent job looking at various cohort studies that have focused on associations of parabens with specifically birth size, and came to the conclusions that just like with most other environmental contaminants that are proposed endocrine disruptors, that most associations really are fetal sex specific. This was really important because when she began this search and was doing kind of the traditional review of looking at the main outcome, not the secondary analyses that were maybe stratified by sex, she really wasn't seeing that there was anything exciting going on until she started digging into the fetal sex specific findings. So you can see here, I'm being very generic with my colors. Blue are associations in boys, and the salmon color are associations in baby girls. BW is birth weight, BL is birth length. And the vast majority of, again, of associations based on that kind of initial literature review appeared to be in one sex, but not the other, and vice versa, depending on the outcome. We also were interested that at the time, again, this is a few years ago, there hadn't been kind of a large study looking at these outcomes in a fetal sex specific manner in the US. And so we thought, okay, we can start looking again, and try to see what we see. So just to give you some context of where we do this research. So I work within the Illinois Kids Development Study, or iKids, and some of you may be familiar with iKids. It used to be an NIEHS EPA Children's Environmental Health and Disease Research Center, much like one at University of Michigan, prospective birth cohort. We began recruitment in 2013. University of Illinois is in Urbana-Champaign. The current study includes just the first 480 women that enrolled into iKids, but they're not any different than the remainder of the population. And the demographics are notoriously Illinois Big Ten campus-based, and some of you might be familiar with that kind of demographic. Women are primarily white, higher educated. They have mostly higher in family incomes and are mostly married. And so that gives a little bit of context for our data. But again, just something to kind of keep in the back of your mind as we go through some of these findings. So again, just to give you a little bit of background on how we approach exposure assessment, since again, this study was designed as an environmental health cohort specifically to assess exposure to non-persistent contaminants. Because of that, we collect a lot of urine. So in our study, women are enrolled at median around 13 weeks, and then approximately monthly, at 13 weeks and approximately monthly, we collect a urine sample for assessment of environmental contaminants. Now, because of the very short half-lives of these, we apply the pooling approach for assessing environmental exposures, in that we actually physically pool the urine sample at the end of pregnancy, or actually throughout pregnancy, and then that is the sample that is actually submitted to the CDC, or Centers for Disease Control Laboratory, for analysis. So in terms of paraben exposure, the CDC provides data on the 4 paraben compounds that, as I mentioned, are also evaluated as part of the NHANES paraben panel, which includes butyl paraben, ethyl, propyl, and methyl paraben. Very similar to NHANES, we have 100% of the women in our cohort have values above the level of detection for propyl and methyl paraben. These are the compounds that are kind of notoriously found in the back of your lotion bottles or shampoos. And then we have slightly less desirable distributions for butyl and ethyl. For butyl specifically, we actually excluded from all kind of statistical analyses and considerations, because the very few, or fewer than half of the women have actually even values below or above the LOD. But for those whose values are above the LOD, the distributions are quite poor. However, for ethyl paraben, we're still able to work with the data. The distributions are actually quite good. We do have values below the LOD that we can peruse and actually utilize, and so we do include ethyl paraben in analyses. Another something to keep in the back of your mind, again, as I present these data, is that paraben levels in our women are quite a bit lower compared to NHANES, and this is always really surprising to me, because the concentrations of most other non-persistent EDCs in our population are quite a bit higher than NHANES, which is maybe not what you would expect. But again, we kind of think that potentially the ability to purchase products with maybe more scent stabilizers in the case of phthalates, or have a certain type of diet maybe is associated with higher use of certain products. And so, but not in the case of parabens, where again, the concentrations are much lower compared to what is reported in NHANES. So jumping right into the results. In terms of birth outcomes in our study, we observed sort of a consistent finding to prior studies in that evaluated associations of parabens with birth size. That parabens were associated with newborn weight and length, but only in baby girls. And so that's what's shown here, that we did not observe any associations of ethyl paraben with birth size, but in terms of methyl and propyl paraben, in terms of both birth size and birth length, we saw negative associations of methyl paraben and propyl paraben with those outcomes, and absolutely nothing happening in baby boys. So in terms of this presentation, where does diet come in? So that'll sort of be the next step in thinking about this particular study. So why consider diet as a potential mitigator, which is the topic of this presentation, specifically related to parabens? So although certainly data on the underlying mechanism of paraben actions are less known perhaps than say phthalates or bisphenols, there is a solid body of evidence both from experimental studies and epidemiologic studies that parabens are potentially pro-inflammatory and pro-oxidant. And we do know that higher quality diets are both anti-inflammatory and antioxidant, suggesting that this could be sort of a viable approach to dealing with some environmental exposures, especially those that are specifically maybe targeting those pathways. In experimental literature, in terms of the intersection of sort of diet and environmental health, the experimental literature is actually filled with examples that have taken that approach of thinking about environmental exposures and diet. But the questions are slightly different. So I'll show you kind of a generic example with fake data. So here I'm showing you a really kind of standard 2x2 study design, what we call. So 2 levels of an exposure to a chemical, a control, and an exposure, and 2 levels of a diet, no kind of a traditional chow or a standard diet, and maybe a bad diet, so a high-fat diet in this case. As you might be able to see from the citations, these are studies we actually conducted back in 2011 when I began my postdoctoral studies in toxicology. And we were sort of in line with other studies trying to understand whether there was a cumulative effect of the 2 essentially toxicants and thinking about the combination of environmental exposures with diet. And that our main hypothesis really centered around this group that was exposed both to a poor diet and had a toxicant exposure in utero or at some other time point. And on the y-axis, we have some very bad thing that was happening to those animals. In my case, I'm interested in cardiometabolic health. So we were looking at specifically epigenetically driven metabolic outcomes in the offspring. And so this is sort of, as I kind of transitioned to environmental health and started thinking about either recapitulating these studies in pregnant women or potentially thinking about other approaches of asking these questions. What was on my mind is, how does this actually translate to pregnant women? And I'm not necessarily saying specifically rodent models or animal models in general, but the entire idea that you're trying to understand kind of the cumulative effect of these dual toxicants, essentially. And the reality is, from my perspective, I had a sort of a hard time coming up with a similar question in pregnant women. And that's really because coming again from the dietetics perspective and from the clinical perspective, we really try to focus on what women should be eating rather than what they shouldn't be eating. So the messaging around diet should be quite positive at a time when a lot of other stressors are occurring and women are sort of blamed for a lot of other things that are happening in their pregnancy. And so the thought from the dietetics perspective is that we really should be doing a better job around positive messaging with diet, especially in pregnancy. And so this is where I was coming from. And so my hypothesis kind of turned into thinking about diet as a potential mitigator of toxicant exposure rather than kind of thinking of all the bad things summed together. So this is kind of where I started in thinking about this research. And as it turns out, environmental health studies have done a little bit of this. So I'll show you kind of classic examples. So one of the kind of more classic studies was from Emily Oken's group, and this is now almost 15 years ago, showing that maternal fish intake moderates associations of mercury with child cognitive performance. And as you may know, actually fish is a source of mercury. So this was a study suggesting that despite kind of the negative connotations of fish consumption in pregnancy, the things that are traveling along with fish that are potentially positive, so things like PUFAs, are actually kind of outweighing the negative associations of mercury exposure with cognition. Another real classic, this is now more than 20 years old, essentially showed that maternal blood lead levels were actually lower in women with adequate calcium intake. So, and were higher in women with low calcium intake. And you might be thinking, the calcium lead connection is sort of kind of random, but kind of thinking back to the nutritional sciences qualifying exam, we know that one of our body's kind of first responses to calcium deficiency is to leach calcium from bone. We also know that lead is stored in bone. And so there's the thought is that when you have a low calcium state or a calcium deficient state, you're leaching lead from bone that you may not actually be exposed to, but you have internal exposure. So this was another kind of important way of thinking about this. And more recent studies just from a few years ago have sort of continued this trend of thinking about moderation of various exposures, including things like PFAS, with birth weight. And again, knowing that fish is a source of PFAS kind of goes back to M-LEEaD's study that I shared kind of in the first, as the first bullet. So again, these examples really kind of confirmed for me that mitigation is what I wanted to think about, and really think about ways that we can potentially benefit women by providing good nutrition advice in pregnancy. So the next question was, okay, we want to look at mitigation of paraben exposures or whatever it might be. What component of diet should we think about first? So this is really a complicated question, as it turns out. And nothing was really jumping to mind for me. Again, coming from dietetics and from nutrition, we really are trained to think about diet quality rather than individual foods or nutrients. And in reality, I'm not an expert on micronutrients, vitamins, or minerals. If anything, I'm trained in macronutrients like fats, fat, carbohydrate, and protein. But even that, I was feeling like I wasn't ready to go back and really hypothesize anything related to any one particular nutrient. So it took some kind of time and thought to figure out what was the next step. But where we landed was to really think about diet quality in pregnancy. And so here I'm showing an example of one diet quality measure that's quite powerful, and it's called the Alternative Healthy Eating Index, or the AHEI. It's alternative because there's also a Healthy Eating Index, but today I'll talk about the AHEI specifically. And it's a measure of diet quality that stresses diet quality over any one particular micro or macronutrient. And importantly, it's based on foods that predict chronic disease risk. And it was developed using the Nurses Health Study and has been validated for numerous chronic disease outcomes in a wide variety of kind of life stages, including in pregnancy. And this is what the AHEI looks like. It's an 11-component score, essentially, that is scored 1 to 10. And most foods, essentially positive foods, or foods that you might think would be positively associated with health, like fruits and vegetables and whole grains and nuts and legumes. A higher score indicates higher consumption of that food. And then foods that you might think are potentially negatively associated with health, like the consumption of sugar-sweetened beverages or fruit juices, trans fat and sodium, are actually scored where a 10 reflects a lower consumption of that food. Now, alcohol is a little bit tricky because the AHEI considers some alcohol actually receiving a score of 10, so moderate alcohol consumption is encouraged. But because we study pregnancy, we actually exclude alcohol from our AHEI, which has been done in the past. So for all of our studies, we actually are scoring the AHEI out of 100 instead of 110, just as a heads up. So in terms of dietary assessment in our study, when I began with iKids in 2013, I added this very extensive food frequency questionnaire, which the women did not necessarily enjoy filling out twice in pregnancy, but we were so grateful that they did. This was a 300-question block food frequency that was specifically adapted for pregnancy, essentially via a lot of research from Lisa Bodner, and validated in pregnancy, and includes some items that are specific to maybe just pregnant women or being specifically critical to pregnant women. So again, in our study, we do this assessment twice. at around 13 weeks, so median 13 weeks, and a median around 36, 37 weeks. And women are asked about their diet in the prior 3 months. So the first FFQ then kind of addresses the conception to the end of the first trimester, and the second FFQ addresses diet somewhere in the end of the second trimester and the beginning of the third trimester. In our study, we're all flunkies in terms of our diet, as much as we'd like to think that we do pretty well. The mean standard deviation was quite low in our women. So again, we scored this out of 110, and the mean was around 52, and the max was not any higher than around 70 or so. Interestingly, early pregnancy diets did not differ drastically from late pregnancy diets. So our analysis includes the mean of early and late pregnancy diets, and we just stratify at the median, which we've kind of validated and confirmed was a reasonable approach. So again, jumping right into our results, just for the sake of being able to move on to other things. So essentially what we observed was that there were no associations of parabens with birth outcomes in baby girls of moms with higher quality diets or diets above the median of the AHEI. And certainly I don't expect you to have memorized the finding overall without dietary stratification. But what I'll point out is these are data in baby girls whose moms had diets that were below the median. And the effect estimates are quite a bit stronger than the effect estimates overall. And the effect estimates are also quite a bit more precise, suggesting that, again, the drivers of the negative associations between methyl or propylparaben exposures with birth size and birth length were really driven by baby girls of moms who were consuming a poorer diet, and essentially non-existent in baby girls of moms who were consuming higher quality diets. So just to kind of summarize this a little bit, we essentially saw that parabens were associated with sex-specific associations or effects on fetal growth, which was relatively consistent with the prior literature in terms of the fetal sex-specific aspect of our findings. And then we also reported that maternal diet quality could potentially mitigate some of these associations. So we're certainly following up on a lot of this within the context of other environmental exposures, as well as various other outcomes, both in terms of birth outcomes and women's health outcomes. So this has really been kind of a passion project that I've really clearly enjoyed and wanted to share with you. So moving on, I'm going to keep talking about the same topic, but jump to sort of the second part of the presentation and think about the dietary assessment piece by itself, so without the environmental exposure. So I already shared our data related to potential of diet to actually mitigate associations of chemical exposures with birth outcomes. But the next question we had, and maybe I had in the back of my head the entire time, was, could we do a little bit better with actually modeling diet quality in pregnancy? And I don't mean collecting diet data and assessing data. That's 10 presentations by other experts. Certainly that's really an issue in the field in general. But once we have data in hand, what can we do to potentially better approximate women's diet quality? And so the question we had specifically was, can we consider other approaches using what we already have in hand to focus on outcome-specific diet quality? And by outcome, I mean pregnancy-specific. And some of you are maybe in environmental health or environmental epidemiology, and you're like, I think I know where this is going. So the first kind of thought we had was, well, environmental health already does this, and we do this in our own hands related to various environmental exposures. But what if we think about mixtures approaches? So again, if this isn't something you dream about or think about all day long, every day, I'll provide a little bit of context for this. So why consider chemical mixtures? So again, the mixtures approaches were developed in environmental epidemiology to deal with a variety of environmental exposures that may be co-occurring and are co-correlated, and that we need to really understand the kind of co-exposure. And so this nice graphic from Science several years ago now really highlights the need for this approach, because we may be regulating each of the kind of colored bars relatively well, in that individually each of these is likely not of major concern. But the reality is that many of these, and in many populations, these are co-occurring, they're correlated, highly correlated, in fact, most of them. And we really are maybe underrepresenting the potential concern around these, because again, people are exposed to many of these concurrently. And so this is very simply the simple kind of version of what mixtures analysis can do for us. It can help us understand the cumulative effect of the mixture and the fact that it potentially could be greater than the individual chemical effects. And finally, it makes it possible for us to identify any potential bad actors, in a sense that it helps us really think about the components within the context of each other. So whereas on this graph, it seems like emissions and waste are potentially most concerning, it's possible that when you take into account all the other exposures, it may be that food comes out, or contaminants coming from the food supply may become kind of the bad guy in the mixture, but we don't have a way of really thinking about that. So this is where we kind of landed in thinking about diet, because in environmental health, we've spent a long time kind of thinking about this idea that we need to consider multiple exposures, and diet in reality is just a mixture of chemicals. And in our field, we do think a lot about diet quality. Certainly, that's our kind of approach for dealing with mixtures. But there are potentially some issues related to kind of how we assess this, and this is what we really wanted to think about. So we took a really small step first. I've already introduced the AHEI. I've already mentioned that we've used it extensively in our environmental health studies. And so we wanted to, before sort of going full force and throwing in hundreds and hundreds of dietary components into BKMR or into some other beautiful mixtures model, we wanted to take a really slow approach and think about, well, so we know that the AHEI, for example, is made out of 10 or 11 components, depending on your research. And does it look the same when you use the traditional method, or would it look different if we actually used a mixtures approach? So this is kind of was our main question. We wanted to evaluate the cumulative effect of all of the components in the index in the AHEI and determine which was the most important for our health outcome of interest. And in this case, we focused on another birth outcome, but this time gestational age at birth, which is, as we know, is a really important outcome in perinatal research. So what are some potential challenges using the standard approach? Again, this is a gold standard validated method for evaluating diet quality, and I would not argue with it whatsoever when it comes to chronic disease outcomes, but it's not made for pregnancy. So in this case, if we're thinking about the cumulative effect, as I mentioned, each of the 10 or 11 components are essentially added together. And so the index essentially assumes that each of the diet components contributes the same to any one outcome. So if your outcome is cardiovascular disease, you can just sum the 10, and that would be the same as maybe pregnancy outcomes. You should just sum the 10 or 11 components, and the approach is essentially consistent across your outcomes. And in terms of bad actors, the AHEI really isn't meant to do that. That's the whole idea of diet quality, is that you shouldn't be isolating pieces out. You should be thinking about diet holistically. But in reality, we know that for public health messaging, we need to be able to at least point to some changes that people can make in their diet, other than saying you should improve all of these equally at the same time. So if we were to try to isolate each individual piece and try to stick all of the components into, let's say, just a traditional multivariable model, we would have some multicollinearity issues, which again is all of the same problems that environmental health scientists deal with when thinking about chemicals. We have multicollinearity issues because stuff is correlated, and we want to understand the cumulative effect. So kind of the example I'll show again is coming from the AHEI, and the outcome in this case is gestational age at birth. And the first, again, question is related to the cumulative effect, and I'll compare the index approach, which is kind of summing all of the components like we did for our Parabens study, versus the mixtures approach, which we used a very traditional standard method called WQS, or weighted quantile sum regression. So in this graph, I'm showing on the y-axis the change in gestational length, and this is specifically in weeks, for each 10-point increase in our dietary index, and then later I'll show it for every 10% increase in the mixture. And so these should be comparable because, as I said, we score our index, we score the AHEI on a scale of 1 to 100, and so 10% is 10 points. So what we see is consistent with other studies that higher maternal diet quality is associated with longer gestation. And in this case, again, it's relatively comparable in that to other studies, in that we observed that for every about 10-point increase in the AHEI index, we are seeing about 0.14 of a week. So that's about 1 day longer gestation, which again is somewhat in line with most other studies. And that makes sense. We have a very kind of generic Midwestern cohort that we're dealing with here. So what does this look like when we actually model this as a mixture? So again, we didn't do anything except throw the components of the AHEI into a mixtures model. And what we're seeing is that our effect estimate has gotten a bit stronger. We've done about a quarter of a day better, which doesn't seem like a lot, but at the population level, it seems quite important. And our effect estimates are quite a bit more precise. We've done this with one other diet quality index and sort of saw very similar results, but except that in that case, the actual standard approach didn't yield significant findings whatsoever, but essentially the mixtures approach provided really, really informative effect estimates and 95% confidence intervals. So again, to us, this suggested that there may be some benefit specifically related to this outcome, so gestational age at birth, to thinking about mixture cumulatively. So the second question is really related, right, to identifying bad actors or the main contributors to the mixture. Again, I will say this upfront that the AHEI was not made to do this, but let's say that you want to do that and you want to tell people, maybe within the context of all of the other things that they're doing, which one is maybe doing the most for them. So I've listed here the 10 components we're using in our study, again, each on a scale of 1 to 10, with 10 being the best. And the first model, and you're welcome to listen to me or to read, it's totally up to you. I know everyone learns differently. So model 1 was essentially what we call the single pollutant model. This is your traditional environmental health approach, where we stick one food into the model and we try to understand what its association is with the outcome. So what we essentially saw was that the best predictors of individually of gestational age were nuts and legumes, so higher consumption of these with longer gestational length, and sugar sweetened beverages or fruit juices. So remember, this one is reverse scored, so lower consumption of sugar sweetened beverages or fruit juice associated with longer gestation. So then we did the illegal multicollinearity approach, where we essentially put all of the 10 components into one linear regression model as a way to try to think about what's most important given all the others, even though they're correlated. And the results were somewhat similar. There's not a whole lot of surprises in this data set. So again, nuts and legumes were positively associated with gestational age at birth, and sugar sweetened beverages, lower consumption of that was also positively associated with gestational age at birth. Oddly, some real odd ducks popped up, and this is likely where we're running into multicollinearity issues, and that I'm not superbly tied to p-values. So just thinking about the strength of the effect estimate, there was something odd going on with whole grains and PUFAs being associated with lower gestational length, which isn't supported by the literature and likely isn't actually true, but it's likely related to the problematic issues we have in the model. And then finally, the last step was to look at this within the mixture. And so in this case, these are not beta estimates, these are actually weights. So the weight of each component that contributes to the whole of the mixture. And so what you're looking for are kind of the bolded items that crossed the threshold of significance for this particular model. And what we were seeing was, again, nothing superbly surprising. So again, nuts and legumes were the greatest contributor to the entire mixture, as was sugar sweetened beverages and fruit juices. But we also saw that sodium and EPA or DHA intake were also important contributors. And the fact that these two came out is likely explaining the fact that the overall mixture is quite a bit stronger than the kind of the alternative approach or the standard approach. So something about the mixtures approach is able to capture components of the mixture that we wouldn't normally see and potentially suggest other, in this case, probably, well, sodium may be a bad actor, but EPA, DHA, good actors. So contributors to the whole that, again, we wouldn't see otherwise. So in summary from kind of this experiment, in terms of the overall index, we saw that the mixture approach could provide more robust and precise estimates potentially, and specifically related to the AHEI and gestational length. That in terms of the individual diet components, we know that the AHEI is not meant to be dissected out that way, but if you want to get that information out of the data, that the mixtures approach could help you identify potentially some unique predictors of gestational length. And so where does that take us next in terms of kind of what we're thinking? So what about other diet indices? As I've mentioned, we've poked around with a few others, but certainly some of this may not be unique to AHEI and maybe the HEI, which is what we've been using. Again, what about other health outcomes? Again, the AHEI was developed with chronic diseases in mind. So it's possible that some of what we observed related to gestational length may not be relevant for like a true chronic disease outcome that was studied and used to develop the AHEI, like type 2 diabetes or cardiovascular disease, which will need to be followed up. Importantly, can we actually put this mixture back into an environmental exposure model? And others in the field are thinking of ways of doing this. You know, everything is essentially a mixture, so we can do a combination of things. We can throw in all of our environmental exposures together with all of our dietary components and see which one sticks, and in that way understand whether or not diet is more important than environmental toxicants, for example. And other ways is literally to essentially output the index and use it as a mitigator variable for, just like we did in our studies with parabens. And finally, the glowing dream, the big picture for long-term, maybe I'll be back, I don't know, in a decade with all of this, is can we actually move beyond kind of a preset set of foods like we did in the AHEI and consider all foods in a mixture model, all thousands of things that people are consuming. Of course, right now, models are not quite that advanced to be able to capture kind of thousands of components. And so that's one reason why we kind of limited ourselves this time, but I really hope that that's what the future holds for us. So main takeaways from today is that maternal diet quality could mitigate effects of some environmental chemicals with specifically in pregnancy with birth outcomes. From my perspective, diet quality is really critical at this stage to try to understand the effects of whole diets rather than individual foods. And statistical mixtures approaches could actually help us get closer to understanding truly what diet quality is in relation to birth outcomes. And then there's kind of a world outside of that and thinking of how that could contribute to environmental health studies. So again, I don't want to forget to show this one more time as a big moment of gratitude to my group. And with that, I'm happy to take any questions you might have. Thank you.
Great, thank you very much. And this is a really interesting presentation and results. And so we have a couple of questions on the Q&A, but if you have any question, please enter your question to Q&A, and then we will cover that after we address these two questions. So Rita, you just mentioned about your main takeaway, but the first question was raised while you are talking about paraben and pregnant outcome. And so maybe this is more, so the takeaway more relevant to the like a paraben exposure among pregnant women. So do you have anything about the takeaway for community members and pregnant people?
Sure. Well, as a kind of perinatal nutritionist, the main takeaway, of course, is to support women in being able to make decisions around diet that kind of we know are beneficial, and we know what people should be eating. It's the support that's probably lacking. So from the diet perspective, that messaging really is really important. So again, diet quality, thinking about whole diets, not focusing on, again, individual foods or, you know, identifying certain foods as bad and really having women zero in on those and kind of not think about the big picture. So for me, from my perspective, again, diet quality, a lot of the, if you remember the things listed in the AHEI, all of those are important. So really helping women, supporting women in making choices that provide a balanced perspective on diet. In terms of environmental exposures, it's really a big question, you know, whether or not diet itself is actually kind of biologically active in reducing the effects of environmental exposures, or if it's some lifestyle factors that track with having a higher quality diet that are impacting this. And this is really what we need to understand. So at this stage, you know, being an optimist, I would say, well, our messaging should be that, you know, we know that women are exposed to a lot of different contaminants. We are doing our bestest to kind of influence government and policy in limiting exposures. Like I said, in the case of parabens, there are companies probably trying to line their pockets a bit by selling more green products, but there are ways of sort of limiting exposures to certain environmental contaminants. But potentially thinking about positive lifestyle choices like improving diets is one way to maybe mitigate those exposures. And that balance is really complicated. You know, what do we focus on? Do we focus on diet? Do we focus on environmental exposures? But that's probably where my head is right now in thinking about all of this. So yes, there was another. Do you want me to take a look at the second question?
All right, so before we cover the second question, maybe, so I want to ask a follow-up question about this paraben. And so you mainly talk about the, you know, the role of this diet as a mitigating factor to, you know, this chemical toxicity. But in this population, have you checked this paraben urinary concentration between like a healthy diet versus because the paraben also used in food and some of the, you know, as a preservative. So do you see any like evidence that like a unhealthy diet increase exposure to parabens?
It's a great question. It's almost like you saw a reviewer comment. We had this discussion in the paper actually, and you're right. So the reason that parabens are FDA regulated is because at a very small concentration, they are also used as anti-microbials in a lot of shelf-stable foods. So I don't know, things like pickles or some of the other things that are sitting on the shelf, and you don't want bacterial growth in those. And so we had a similar concern. It would be kind of the same, you know, kind of building a DAG with something that is potentially a source of your chemical feels like a no-no. And so we did confirm that parabens were not associated in our population with diet quality. So specifically AHEI and AHEI as our moderators, there was not kind of even a sense that there was a correlation between diet quality and either of the two kind of methyl or propylparaben, which is where we saw the most kind of strongest effects. So we had kind of a similar concern. Again, the examples I gave with methyl mercury and PFAS, despite the fact that fish is a source of those, it seems like, you know, there was the potential for fish itself to kind of overcome the effect of the toxicant. We wanted to avoid that a little bit. So we wanted an exposure that truly wasn't associated or wasn't a source of our, or a mitigator that wasn't a source of our exposure. I don't know, you know, in the case of things like phthalates, which we know are strongly tracking with diet quality, if we would see what our interpretation would be if we did a similar study. But it's a great question that in the case of parabens, we were kind of relieved to see that that wasn't an issue that we were having to deal with, or a discussion that we had to, an additional discussion in the discussion section. Yes.
Okay, great. Thank you. And then second question, maybe you already look at from the Q&A. So was potential dietary exposure to pesticide from fruit and vegetable considered in, I think this is for the your second study, right? So have you thought about this pesticide and food together?
Yeah, so if I unblur my board, there will be some sort of thought. You can't see it now, but we're really trying to understand diet sort of. So one of the kind of things that we're interested in my group is dietary sources of environmental exposures. And so your question about parabens is kind of in line with that. And we found that no, in terms of diet quality, we're not seeing that. But in terms of pesticide exposures, it's not something that we study in our group, but we're really interested in. So we've been giving this a lot of thought. And again, trying to understand in our population, fruits and vegetables are actually a little bit higher in terms of consumption patterns than maybe in others. But what does that mean? We have quite a bit more of kind of organic food consumption. What does that mean for us? Does that potentially eliminate some of the concern around the vast majority of kind of traditional pesticides? And so we're certainly thinking about it. It's a really complicated question because the model building is really, it's like a double mediation with a lot of different pieces where you know that your chemical is potentially associated with the outcome, but is that because, and diet is associated with the outcome potentially, but is that just because the chemical is the mediator of the diet outcome relationship? We don't know, or the opposite, kind of all the different ways you can think about it, but it's a really great question. We weren't able to assess that in our study, but we're very interested.
Okay, great. Thank you very much. So now 12:52. So unfortunately, we have to end this presentation and then talk. And so thank you, Rita, for your excellent presentation. And then thank you for everyone attend this seminar. So one announcement. So the next week, so that we will have our second residents and researcher webinar about water and public health and inequity and affordability. So you will receive an official announcement about this webinar. So please attend and stay tuned. Thank you very much.
Thank you.